Hello everyone. This video I'm going to show you the shear stress calculation on the boat. Okay, in previous two video we only has the shear force calculation on the boat, and here we have to calculate shear stress. Yeah, shear stress on the boat. Okay, and yeah, this problem, yeah, it's not only has the one bolt again, because in previous two example, yeah, here we only has one bolt. Yeah, this is one bolt, and this is two bolts. And here is a problem, and we have two bolts and hold these three pieces together. Okay, and this is the external force on these pieces. Okay, he said determine the maximum average shear stress developing in each 12 millimeter diameter bolt. Okay, so it gives you the diameter of the bolt. Yeah, you can use this to calculate the area of the bolt. Okay, he say he want to determine the maximum average shear stress, and shear stress is shear force divided by the area. So if you want to determine the maximum average shear stress, that means you have to find out the maximum shear force. Okay, maximum shear force lead to the maximum shear stress because the area is the same. Okay, and so this problem, I think it's better to draw a scheme of this problem. Okay, okay, because this problem right now is kind of difficult. This picture is kind of difficult to and do the analysis. So I just draw. Okay, I just focus on the one bolt. Okay, the bolt is like this. Okay, this is the bolt. This is the bolt. This is the bolt. Maybe it's not very right. It's not very. I didn't draw a very good picture. Okay, so and this bolt. Okay, this bolt. This bolt holds three pieces. Okay, these three pieces is here. Okay, the first piece is here, and the second piece is here, and the third piece is here. Okay, and let's give these pieces a name. I think it's better to give them a name. Okay, so it's A, B, C. Okay, and this external force is, okay, 5 kilonewton, 5 kilonewton. No space here. Okay, I just right here, 10 kilonewton. Okay, so in previously, okay, when we try to analyze the force on the boat, I said I start from the middle first. Okay, start from the middle one first. So for this problem, I think yes, we still start from the middle one first. Okay, middle one looks like much easier to do the analysis. Okay, so we start from the middle one. The middle one here is B. Okay, and he has 10 kilonewton external force, and B contact with A, and B also contact with C. So when I apply a force on B in this direction, the B is subject to the friction from A and C. Okay, because B contact with A, B also contact with C, and this is the shear plane. Yeah, draw this. This is shear plane. B contact with A, and B also contact with C. So B is subject to the friction from A and C. Okay, so since B in this code everything is static, so the friction force must hold the B, okay, to prevent from translation. Okay, so this is from A to B. This is A to B. Okay, and this force is C to B. Okay, they must be equal to each other and hold the B from the translational motion. So this must be 5 kilonewton here, also 5 kilonewton here. Okay, so we this is the free body diagram of B. Okay, and so we can keep moving. So B contact with A. Okay, and B also contact with C here. On A, and there is an external force on C. It's here. Okay, and so because we A has a force on B, okay, so at the same time it must be a reaction force that B acting on A, that B acting on A. Okay, so there must be equal and opposite reaction force. This is A to B, and here must be a equal and opposite. This is B to A. Same thing here. There's a force C to B. C make force exert force on B, so there must be a reaction force is B to C. Okay, B to C, and because it is equal and opposite, so this must 5 kilonewton. Okay, and this must be also 5 kilonewton. Okay, so after we do this, we found that okay, the force here 5 kilonewton to the left, and this is 5 kilonewton to the right. Yeah, we found its balance. So okay, so that's it. And here is 5 kilonewton to the left. Okay, and there's the external force 5 kilonewton to the right, and you see the all force acting on B is balanced. Okay, and here all force acting on A is balanced. Okay, so we see here is balance. Okay, here is balance, and here we also balance. Balance. So we found everything's balanced. Okay, so we just stop here. Everything's balanced, very perfect. Okay, very perfect. So we don't have to think anymore. Okay, everything's balanced, very perfect. Okay, and that's it. Finish. Finish. Okay. Okay. Um. Maybe someone said, do we have to do the analysis on here? For example, here. For example, okay. So someone said, do we have to do analysis on here, or maybe I use another card? Do we have to do any analysis on here or here? I think we don't have to analyze on these two planes, okay? Because shear force, yeah, simply speaking, the shear force only happens on this shear plane, okay? And these two planes, because there is no external force, so I don't think we have to analyze anything on these two planes. We only have to consider this middle two plane. These two planes, there is no external force acting on it, so we don't have to consider them. Okay, so and then after this analysis, we found everything is balanced, everything is perfect. And also, we only consider with everything inside the ABC. For these two parts, outside ABC, we don't have to consider that. Okay. Okay, so let's say everything is a perfect balance, everything is perfect. Okay, so we see what's the magnitude shear force. Okay, shear force here, shear force here, shear force here, shear force, and we all found it's all 5 kilonewton. Okay, so 5 kilonewton is or shear force actually is 5 times 10 to the power 3 newton, and we divide it by area is pi over 4, and the diameter is 12 millimeter diameter, so it's 12 times 10 to the power minus 3 square. Okay. Okay, let's see what is the value is. I think we can write here, so 5,000 pi 144 and times 6. Okay, I think it's p units p. So okay, so let's see. Okay, 5,000 divided 144 divided by 3.14 and times 4. Okay, so it's 44.2, and 10 to the power 6 is mega, so it's mega power. Okay, Okay, so it's megapart. So is this the correct answer? Yeah, you see the answer is not is not the answer. The correct answer is 22.1 megapart, but we up get the 44.2 megapart. Why is that? Because this analysis will only analysis on one boat. Okay, one boat. But actually, in these two systems, we have two. In this system, we have two boats. The other boats also share the force. Also share. They share. Also share. The other boat also share the force. So this value should be divided by two. Okay. Okay, so for to MPa divided by 2 is equal to 22.1 MPa. Because we have two bolts, this analysis only one bolt. Okay, because but we have another bolt to help you to share the force. So that means, and you can think another way, we have a double the area. Okay, because in this problem, we only have this area. Okay, in this spot we only have this one area, 1A. Okay, because but right now we have two bolts, so that means we have double the area, so we have divided by two. Okay, we double the area. Okay, in this two pole we have double area, the OUB double area. Okay, because we have two bolts, we have double area, so we have to divide by two. Okay, so okay, so let's list the two bolts problem. Okay, yeah, I hope you can understand this. Okay, okay, so I just start the video here. I don't want to make the video too long. Okay, see you in the next video. Okay, bye bye. Bye bye. Wait, wait, wait.